of tabular presentation when presenting data in the form of tables, and then when you're presenting them in the form of graphs. What are their importance? So data is a plural word and datum is singular. So this is something that needs to be known. It's any piece of information about any characteristic that can be measured, judged, assessed or observed. Okay? So there are different types of data. For example, there's raw data, which I told you. Files, for example, primary data that has unnecessary, irrelevant and unwanted information and has not undergone any statistical treatment. What is statistical treatment? You need to take out some information from the data and you need to put in all the information that you need at that point in time, which is required. Okay, that is called raw data. Then that goes towards treatment. You treat that data. You take out all the unnecessary information and that becomes secondary data that is cleaned by removing all the unwanted, irrelevant, unnecessary information, and then it's given some statistical shape. It's given some numbers. It's given some form to be presentable. Then there's ungrouped data, which is observed and analyzed individually. It's for every individual. Okay? For example, the data on number of children of 6 families. Okay? There are 6 families. Usme pehli family has 2 children. The second family has 4 children. The third has 4 children. The fourth has 6 children. The fifth family has 6 children, and the 6th family has 6 children. This is every individual is being counted. Okay? For example, whenever we are doing our census data. And then there's group data, which is identical data when it is grouped by frequency, number of people. For example, it becomes easier in understanding. Okay. For example, when you want the data on the same number of children of these 6 families, you take the first family and you record how many children there are. You take 2 families again who had 4 children, and then you have 3 families who had 6 children. So this is called group data. You can group it in any other way. It's all up to you. Okay? However you want to make it presentable. So we're talking about how to present your data. Okay? Now a bit about types of data. So when you understand what are the different types of data, only then can you understand which type of presentation will you choose for your quantitative data or your qualitative data. Okay? So quantitative data, it's continuous measurement. It has fractions. Okay? The data that are measured on a naturally occurring numerical scale. For example, you have heights. Some people have height if 5 feet 9 inches, for example, and 5.9 inches. So it's like it has points, it has fractions. And the same goes for weight, age, number of children. Okay? And then there's qualitative data in which you have categories. The data which cannot be measured on a naturally occurring numerical scale, it can only be classified into a group of categories or classes. For example, when you have severity of pain, you have gender, for example, male and female. You have nationality, for example, Pakistani, Indian, American, etc. You have religions, different religions, for example. This is known as qualitative data. So this is just a quick recap. So data is of 2 types. You have quantitative and qualitative. In quantitative data, you have an interval scale, you have a ratio scale. Okay? In ratio scale, you have discrete and continuous type of data. Qualitative, you have nominal and ordinal type of data. We'll talk about all of these in a short while. So nominal data are those type of data when the variables are named or into categories, but they are unordered. They don't have any specific order, unlike the ordinal data. They cannot be ordered. They can their setting or their arrangement is up to you, entirely up to you. And for example, the male and female, male does not come before, female does not come the next. Marital status, for example, single, married, divorced, widowed, whatever sequence you want, it is up to you. Then there's ordinal data, in which the data has distinct orders, okay? And they're placed in a meaningful order. Okay? For example, you have degrees of pain, which are mild, moderate, and severe. You have heights, you have short, medium, and tall. You have grades, you have the lowest to the highest grade, or the highest to the lowest grades, etc. Then there's an interval scale and a ratio scale. Please understand these 2 points. The scale that has a 0, that is not actually 0. It means there is something. Okay? For example, temperature. Or I give another example of IQ. So when there's 0 degrees centigrade, that does not mean an absence of temperature. It is towards the freezing point, but that does not mean that there is an absence of temperature. There is some temperature at that time. The same goes for IQ levels. Then there is a ratio scale, where 0 means it is actually 0. When there are, I have 0 patients today in my ward, that means I have no patients at all in my ward. That means it has actual value. For example, there is a child born of 0 days. That means that child is just been born, just been delivered. So that child has no days to count in his or her age. Okay? So number of children and patients. And continuous data, then you have continuous data in which you have fractions, for example. Okay? So qualitative data, may you have, what options do you have for qualitative data? You have bar charts. For presentation of data, you have pie charts, and you have simple and frequency tables. You have simple tables and then frequency distribution tables. And then you have quantitative data. This may you have discrete type of data or continuous. Discrete means, for example, the number of patients, number of children, in which you do not have fractions. Okay? And in that case, you have simple and frequency distribution tables. You have bar charts. You have histograms of histogram of frequency polygon. You have scatter diagrams, and then in continuous type of data, you have frequency tables. You have histograms of frequency polygons, and you have scatter diagrams. So coming towards a simple table, what are the parts of a statistical table? This is, by the way, a table in which you have the table heading. This comprises of the body of the table. These are called the stubs. And this is the box head. Okay, where you have all the labels here. And then at the end, you give the footnotes or the sources of data. Okay, so the heading has a number and title of the table. The stubs classify or show the categories. They're typically found at the left side of the body of the table. This always happens. This is the norm. Then you have the box head. Okay, this is the box head. On top of the columns, you have the body, the main part of the table, which comprises of rows and columns. You have footnotes. Additional information can go into that, and source notes, where you give your sources, okay, your references. So coming towards frequency distribution table, I am sure you must have done it earlier also, or if you've not done it, you'll be practicing it later on. So these show frequency of any distribution, okay, of your data. For example, the example that I gave you of the families. For example, 3 families had 6 children. Now this showing that how many families had the frequency of children of every family. For example, you have a data value of 2. There are 2 families in which there are 3 children. Okay? So these are the values that you need to remember. That will be part of the frequency distribution table. You have the data value, the frequency of how many, for example, we'll take the number of children only here. The number of children that were present in that family. This is the cumulative frequency, the accumulated frequency of all these people. The relative frequency, okay, this is when you're comparing each family with the other. And then cumulative relative frequency. This is giving percentages to all of the families. And that's how this happens. Like for example, there are two families which have number of 3 children. Okay? So this 3 will be part of the cumulative frequency. And when you go to further on, for example, there are 3 families that had 5 children. Now what do? You add this 5 to this 3. Okay? So this becomes 8. So this shows that when you take the cumulated number of these 3 families and below, so 3 families or even less than 3 families have how many children? They have 8 number of children. The same goes for further on when we go for the next family which had 3 children. 4 families had 3 children. So you're going to add this 8 to this 3 number, and then this family had 11 children. This means that 4 families or below those families, for example, 3 families, 2 families, they all, when you combine them, they have 11 children or less. Okay? So the same goes, this will be applied to all the next rows in the whole column. Okay? And then when you have the relative frequency, you are going to divide the total number of cumulative frequency. The total number of cumulative frequency will be divided by that actual number of frequency. For example, 3 divided by 20 or 0.15, 5 divided by this frequency divided by 50 or 0.2, sorry, this is a typo, 20 or 0.25, and then 3 divided by 20 will again give you 0.15. 6 divided by 20 or 0.30. This is a relative frequency. And then cumulative frequency is again combining 0.15 to the second number. So 0.15 plus 0.25 gives 0.40. So this shows that 0.40 or 4% of the families had 5 children or less. Okay? So I'm just giving you an overview of this frequency distribution table. This will be, you will be required to calculate the frequency distribution tables, all these types of frequencies in your tutorial in greater detail. I'm just giving an overview of it. So this is also part of it, but I think we can skip this. Okay. So coming towards the graphs, this is one way of data presentation. So you can present your data in the form of a frequency distribution table. Now next come graphs. Okay? These help the whoever's taking the whoever's reading the graph, or whoever's taking the data, whoever's the recipient of the data, should at a glance understand what the graph is showing. And they should be self-explanatory. And how do you read a graph? You read the title of the graph, which comes at the beginning. You read the labels and a range of the numbers along the side at the vertical axis and at the horizontal axis. You determine what units are used in the graph. Okay? And then you, this can be given in the legends. For example, legends are some boxes that are given at the side of every graph, so that a clearer understanding can be given of each section or each part of the graph. And then you look for patterns, groups and differences in the graphs. For example, this is the simplest type of graph, which is called a bar chart. Okay? So for example, this is a graph that is showing the number of procedures that have been taken place at a hospital. So the largest number is given to the DNC, and here you have the percentages. On the x-axis you have the types of interventions. So you have DNC, you have laparotomy, you have intestinal resection, you have abdominal surgeries. Okay, so this is very clear, and the length, the height of each graph shows the magnitude of each column, or each bar shows you what is the frequency, what is the percentage of these procedures that occurred. It's an easy way of expressing nominal or ordinal statistical data. You can use it for orders or for data that doesn't have any order, for example, male and female. So the categories are given on the x-axis. You can keep them on the y-axis as well. Okay? This x-axis is known as abscissa. You can also call it abscissa, and the frequencies are given mostly on the y-axis, which is known as the ordinate. Each axis is labeled accordingly, and the length of the bar, as I said, is proportional to the magnitude of the variable, and the bars are separated by appropriate spacing. For example, this is a graph that has a label. This shows the top 5 countries where women are expected to live the longest, life expectancy at birth by 2030. And then you can see that South Korea tops all of them, 90 years and above. Women can live for 90 years and above. And then comes France, Japan, China, Spain, Switzerland, and Australia. So this is a very clear description of the life expectancy of women. Then comes multiple or compound bar chart. Now this was a bar chart, a simple bar chart that has simple bars stacked like they're placed one after the other. Now comes multiple or compound bar chart, where 2 or more than 2 bars pertaining to the same category can be grouped together. For example, you have this graph on this is a bar chart. Okay? Very clearly this is a bar chart, and what does this show? Sorry, this shows different under 5 mortality rate per 1,000 live births by the level of household wealth. Okay? And this shows this is for Uganda, for India, for Turkmenistan, this is for Peru, and for Morocco. Okay? And these are the footnotes, and this is the source of the data. It's taken from DHS. Now, as you can appreciate that the x-axis or the abscissa has the countries. Okay? These are all the countries, and the y-axis has the frequency. Okay? Starting from, okay, now under 5 mortality, we are talking about under 5 mortality per 1,000 live births. So these are the number of deaths that are occurring. So these are 0 deaths, 50 deaths, 100, 150 to 200. Okay? And what are these gradients? These are the gradients according to the economic status of each country. For example, if you take the example of India, so the poorest have the largest number of deaths in India. This is for the 98 to 99 data. Okay? Then the less poor have lesser number of deaths, followed by the middle income people, less rich people, and the richest people have the lowest number of deaths. So as you can see, these are multiple bars that are placed together. There are 2 or more than 2 bars that pertain to the same category, and they're helping in comparing India and different countries. Compared to Uganda, what's the death rate in India? What's the number of deaths or the mortality that is occurring in India? And then the richest and the poorest can also be compared. Okay? So the least number of deaths are occurring occurred in Morocco in the year 2003 to 4. Okay? And when you see Peru, the richest people had the least number of deaths. Even in Uganda, if you see the richest people, even they had increased number of deaths compared to all the other countries. So this is a way of comparing different categories of the data. Then you have the component bar chart, in which every bar is divided into different components. Remember it in that way. So there are simple bars that are divided into 2 or more components, representing the magnitude of that variable. So the length of each component will be showing the frequency or the magnitude of that data. So for example, there's a program budget expenses by major office and categories in 2018, US millions में, and there's Africa, there's Americas, there's Eastern Mediterranean. These are all the continents that are the WHO regions, sorry, that are divided. You can see them in the abscissa, and then in the y-axis you can see the expenses by the major offices and the categories. Okay? So you can see, and here you can see for Africa, for example, there are different categories. Now, for example, for communicable diseases, you had around $100 million that you spent on communicable diseases. And then the least share is for non-communicable diseases, which can be seen by the pink colors. Okay, so this is, and polio eradication, for example, had a large chunk here for in Africa. So if you can see that polio eradication was not very significant in let's say Western Pacific. Why was that so? Because there is no polio there. But our EMRO region, where we are here in Pakistan, we have a large chunk of polio eradication budget that was spent. Okay? And then followed by humanitarian response and other appeals. Okay? A large chunk was shared for them. But for communicable and non-communicable diseases, total expenditure was not too much. This is for our part of the region. Then this is another graph, a component graph, that component bar chart that is showing the cases of infections that occurred by male and female. This shows the age groups, and this shows the proportional distribution by sex. Okay? So these are types of component bar charts. And then you come towards pie charts. Okay? Pie charts are mostly used for nominal data that don't have an order. Okay? They are a powerful way of expressing the distribution of frequencies, the percentages of qualitative data. Okay? So ideally when you have data that has 4 or 5 categories, not more than 5 categories, because then it becomes clumped up, you can't make much out of it. So that is when you use a pie chart, and it's a very powerful means of presentation. And it may be constructed by using the formula, which gives relative frequency divided by 100, and you multiply it by 360, which is the area of the pie. And then that is how you have the share of each percentage here shown by the different slices of the pie. Okay, these are 2 examples that are given. Now you have quantitative type of data. That earlier that we talked about was mostly for nominal type of data, in which you have categories, for example, in bar charts, or you have nominal data where you just where you don't have any categories. That is for the pie charts. Now coming towards continuous type of data, for that you use mostly histograms. They are simply a pictorial presentation of frequency distribution tables that we already talked about. Okay? And it's used for continuous type of data in which you have fractions, and it has bars which are placed side by side. And please remember, the difference between a bar chart and a histogram is that bar charts have spaces in between them, but histograms will not have any space between them. The only space that can be appreciated would be because whenever you have a category that has 0 frequency, okay, that is when you might have a distance between one bar and the other bar. Okay? Otherwise, they are for continuous data, they do not have any space in between. So the gap only occurs if the class has 0 frequency, and the x-axis represents the class intervals and the y-axis represents the frequency. So for example, you have different age group women, okay, and the number of children that they have. Okay? This should be having a label also. It has a label missing here. However, we will proceed with this. The age group, for example, women who are 32 to 37 years of age, they had two children. compared to women who are older, of older ages. Now then, when we have women who have who are of ages 52 to 57 years, they have 8 children or more. Now please remember, this does not mean that these women are producing more children. No, you just have data. You take the ages of the women and then you ask what is the number of their children. They could have had children when they were 18 years old, and now when they are 52 to 57 years old, they tell you that they have 8 or more children. This is actually of data of multiple women that has been taken, and then their ages have been computed, and then the number of children have been taken. Now remember, age is a continuous type of data, hence you plot it on a histogram and you don't have any space in between the bars. Coming towards the frequency polygon, sorry, it is constructed by marking a point at the same height as the histogram bar at the midpoint of the interval. For example, when I talk about this this histogram, the first point that I will have will be on the height, on the midpoint of the height of this bar, which has 32 to 37 years women. I will follow this bar and I'll go towards the second bar to the midpoint, 37 to 42 years, followed by 42 to 47 years, and then 47 to 52 years, and then I'll go towards the highest peak, 52 to 57 years, and then my bar will go down and then up again, and then up again. That's how it will go, and it can reach the x-axis also. When the, for example, if I want to know the number of cases that occurred of any disease, these are the number of cases and these are the number of months. So I'll start from when there were 0 cases, starting from January, February, March, April, the number of cases is rising, and then it's decreasing again, and then it reaches a 0 point after December. Okay? And then you have the third type of frequency, the graph that is used for continuous type of data. It's known as cumulative frequency polygon. Its second name is ogive, O-G-I-V-E. It's not pronounced ogive, it's pronounced ogive. This is again a type of frequency polygon, but it shows the cumulated number of cases where the bar never touches the x-axis. It's accumulated and it goes on a height and it continues from there. So it's a horizontal scale. The horizontal scale is the same, but the vertical scale indicates the cumulative frequencies. So they're increasing in number, okay? And it's represented by a smooth line on the graph. Okay? It shows a smooth line on the graph. And it's useful for determining the interquartile range and the median of the data. I'm sure you must have done that. Okay? So this is an example of the COVID-19 cases in Pakistan. So these are all the cases that occurred through June 2020. Okay? April to June 2020. These are the number of cases that occurred. Okay, then you have another type of graph that is known as scatter diagram or scatter graph. Okay? It represents the relationship between quantitative variables. Okay? And it's there's an independent variable which you have on the x-axis. Okay? And then you have a dependent variable which goes on the y-axis. Okay? And this is this 1 point represents one piece of information, 1% or 1 person, that is for example, if you have the weight in pounds of people here. So this 1 person, his weight in pounds was 110 lb and his height was around 58 in inches. Okay? So this is how you show individual data. Okay? But this is again for continuous type of data, and as you can see, as the weight increases, the height also increases. Okay? So and there's also a decrease when you increase, they have excess increase in the weight. There's a decrease also in the height. Okay? So you have an independent variable where the height, the weight is independent, and the height is actually the dependent variable, which is on the on the y-axis. Okay? So for each subject, a pair of reading is taken with respect to each variable, and you can see, for example, for age and for IQ. For example, you have age over here on the x-axis, and then you have the IQ on the y-axis. So we want to show that with increasing age, you have an increase or a decrease in the IQ level. So this is again for continuous type of data. There can be trends that can be determined by the use of a trend line. So if this shows a straight line, it means that it follows a trend. So with increase in weight, there is also an increase in the height. Then there is a line graph. This again shows trends or predictions. Okay? For example, you need forecasts or you need predictions. So this is used to show the trends of events with the passage of time. Okay? Is there an increase in number of cases or a decrease in the number of cases, anything. So future predictions can also be presented in this. For example, the change in the number of work-related diseases by disease classification and other than diseases caused by injuries. This is data from 2004 to 17. So this is showing a trend in all the number of work-related diseases. So, and these are the legends that I was talking about. These are legends. So I don't know what is this yellow color for, but when I see these legends, I know it is for pneumoconiosis and complications. Pneumoconiosis is a work-related disease. Okay? So as I can see that the number of pneumoconiosis cases decreased from 2004 to 2017. It might have happened because of protective equipment that was used, or because of any other reason, or because of information, better information. Then you have diseases due to physical factors. You have there's an increase from 2009 to 2010, and then a steep decrease in 2011 in due to the diseases that occurred because of physical factors that included high or low temperature and atmospheric pressure. Okay? And then the trend goes is variable from there on. Okay? Now we can see that this gray shade is because of chemical substances, diseases due to chemical substances, which has always been on a lower side. Okay? There are slight fluctuations, but it's on a lower side. Then you have the last small chunks are because of mental, they represent mental disorders or other occupational diseases. You don't have much data. So it's shown only from 2014 to 2017, which shows a very low number of cases, probably because of the stigma that is attached to information sharing. So there are some other graphs that I'll be pointing towards. These include pictograms, for example. So yeah, so a pictogram, it's a pictorial presentation of data for easy understanding by common people. So for example, a layman, he cannot read a mosque written anywhere. But when you have a picture of the mosque, he will be able to he'll be directed towards that mosque by just seeing the picture. So yeah, so it's a very important type of graph that is used for small data, and each picture represents a definite quantity, and it should include a scale also. Okay? For example, this is a pictogram depicting the population of 5 cities, A to E. Okay? So city A has this number of people, city B has this number of people, city C has the least number of people, city D has the greatest number of people. The total number of people are around 0.1 million. Okay? Then you have categories. For example, this is the key legend. Okay? This shows that this one person is equal to 10 people. Okay? So for example, France, you have these icons or you have these symbols. and for Germany you have these people, this number of people. Okay? So these are different categories given to the same pictogram. Then you have health in numbers, for example, doctors available per 1,000 people. So there are different countries that show different number of doctors that are available for example, Cuba, for Spain, and for Canada. Okay? Doctors, so this shows that there are very few doctors available for around 1,000 people. So this shows there's a deficiency of number of doctors compared to Cuba. So this is also a way of comparing data and then presenting your data. And then you have this data presentation on different software, for example, Microsoft Excel, and on SPSS. I've just given this example of a pie chart that can be shown on Excel when you present it, or on SPSS. Okay? You can have different types of graphs. You can have histograms, you can have bar charts, you name it. Okay? All of the graphs can be made on both these softwares that we use for our publication purposes, and that's about it. Now coming towards the advantages and the importance of tabular presentation, and when you present your work in the form of graphs. It helps in easy visualization of data. When you have statistics, when you have a huge number of files, you have huge number of data, you cannot show individual files. It's very, it gives important description of data. It helps in easy visualization. It helps even the layman to visualize the data meaningfully. And it gives a summary of the overall work and the interest that people show to graphs over words. Words are not so appealing compared to graphs. And when you come towards tables, they're useful for data with specific amounts rather than approximations. You can't make good comparisons with tables. They're not very good. And however, they take viewers and they take, it takes longer for a person to comprehend and read the table compared to a graph. And they do not provide simple methods for capturing trends in the data, compared to graphs when you see a trend in the data. And the reviewer needs to connect between different types of data. So it's not very simple reading a table for the viewer. However, graphs are useful for comparison of data. There are circle graphs. They are used for situations in which it is beneficial to explain how one section of the data impacts this entirety. These are known as pie charts. You have bar graphs, which help explain and provide visual display for trends, and you have computation for graphs that are more difficult when you have proportions and percentages compared to tables. They're a bit more difficult in drawing them. However, when you have your softwares, they're easily constructed. Okay, do you have any questions? I'd like to take them.